Hello, everybody. I'm here to talk about the lab that we're doing this week. We call it Fire in the Sky. And the reason we call it that is because a lot of the chemicals that we're going to be testing are used in fireworks. Kids love this lab because for multiple reasons. One, you get to play with fire, you get to learn how to use the Bunsen burner, and you get to make pretty colors. So this is a lab, generally speaking, that kids enjoy doing. They don't always necessarily enjoy the planning part because it does involve an experimental design. So first, let's talk about an important concept that you need to know prior to doing the lab. We're going to be testing what are called ionic compounds. And ionic compounds always have two parts to them. They're composed of ions. Now, you may have learned a definition of an ionic compound as the exchange of electrons. That's partially true, is we have different elements will exchange electrons. We get a positive ion, a negative ion, and then those ions are attracted together because opposite charges attract. Now, an ionic compound has two parts, a cation, which is a positive ion. It's always written first in the compound. An anion, which is negative, is always written second in the compound. So I have three examples here of ionic compounds: sodium bromide, calcium chloride, and copper 2 sulfate. Sodium bromide is made up of sodium ions and bromide ions. Calcium chloride is made up of calcium ions and chloride ions. Copper sulfate is made of copper ions and sulfate ions. Now, one thing to note, some ions, mostly they're anions, will have more than one atom. So for example, SO4 is called a polyatomic ion. There's more than one atom in that, and that overall has a charge. That is what's attracted to the copper. Now for this experiment, the magnitude of the charge, whether you're dealing with a +2 or +1, and the number of atoms, so here I have 2 chlorines or 2 chloride ions, here I have 1 bromide ion, it's irrelevant. It really doesn't matter. All we're looking at is the cation and the anion. Now the questions that you need to answer, there's two parts to this experiment. When I take sodium bromide and I put it in a flame, and you will see examples of this on the second part of this video when I demonstrate how to do this. When I take sodium bromide and I put it into a flame, I get a color. When I take calcium chloride, I put it in a flame, I get a color. Copper sulfate, I put it in a flame, I get a color. We want to know, is it the sodium or the bromide that causes the color? Is it the calcium or the chloride that causes the color? Is it the copper or the sulfate that causes the color? The cation causes the color or the anion causes the color, and that's what you need to determine. Now I have highlighted in here, there's two parts we're going to do this. The first, you need to answer the question, does the cation cause the color? Does the sodium, the calcium, the copper cause the color that we see in the flame? The second part, does the anion, does the Br, the CO-, or the SO4 2- cause the color? Within these questions, and I have it highlighted for a reason, the independent variable and the dependent variable are identified. This is going to be an experimental design lab where you are going to only change the independent variable. So once you identify the independent variable, that is the only thing that can change. And a major hint I'm giving you, within each compound, within sodium bromide, within calcium chloride, within copper sulfate, within whatever compound you're testing, there's an independent variable and there's a constant. Okay? That's my big hint for this experiment. So once you identify the independent variable and the dependent variable, you need to set up an experiment. You are going to test the independent variable only, and you are limited to 9 individual tests. You are limited to 9 splints dipping in the flame, and you need to make sure you include multiple trials. And remember, the minimum number of multiple trials is 3. So that should give you a hint on the number of chemicals you need to test. You need to choose wisely because a portion of your grade is going to be based on, did you choose the appropriate chemicals? There is a correct answer for part 1 and a correct answer for part 2. The chemicals you use for part 1 are not the same as the chemicals you use for part 2. Now this is the chemicals that you use for part 1, and I cut this out of the lab sheet. So you have a choice of these right here. Okay, so you're going to choose the appropriate chemicals you want. You're going to go up and get them from your instructor, and then you're going to test them the way that is demonstrated in the next part. 2 experiments in this one. We're doing 2 questions that we need to answer, and then you're going to use your data to write a conclusion. Okay, prior to doing this lab, your instructor is going to show you how to properly light and adjust the Bunsen burner. So I'm going to leave that up to your teacher. Right now I have a Bunsen burner that's properly adjusted, and as you can see, it is completely blue with no yellow in it, and I have that inner blue cone nice and sharp right there. And that is exactly what we are looking for in a Bunsen burner. And it's only probably about 2 inches, maybe 3 centimeters high. We don't need anything bigger than that. Now, once you have figured out the chemicals that you need, you're going to have some weighing dishes. You're going to label it with the chemical you need, and you're going to bring it up to the desk, and your teacher is going to give you a tiny, tiny bit. Now, I'm testing 2 chemicals here, 2 compounds. Just because these are the 2 I'm testing, that doesn't mean that those are what you are going to be testing. This is just what I grabbed to show you the procedure. So you have your Bunsen burner lit properly. You're going to have some wood splints that are sitting here in water. They're going to be soaked probably for the day, so they'll be good and wet. You're going to take 1 wood splint. You're going to dip it in the chemical so that you get a little bit of chemical on there, and then you're going to burn it. Now this one, we're getting obviously like a greenish color. When you're done testing the chemical, you put the splint in the empty waste beaker. Be careful to not put too much of the chemical on the splint because it will drop into the Bunsen burner and mess up the Bunsen burner a little bit. Okay, so again, to repeat, you're going to take your wood splint, you dip it in the chemical, and then you put it in the flame. So here we're getting a little bit of a different color. On the camera, it doesn't look exactly the same. It's actually like a light purple color, the kind of a purpley orange actually in real life. And then you put it into the beaker. Now remember, for your experiment, you need to do a total of 9 individual tests, incorporating multiple trials. So that would be, I did 1 trial with the copper, there's a 2nd trial with the copper, and there's a 3rd trial with the copper. Okay, so don't forget that in your experimental design. Safety equipment, you are going to need goggles, you're going to need aprons. Girls, you need to tie your hair back.